Okay, so in a circuit, we have charges moving around, and they're getting pushed basically by the battery, which provides a voltage. Battery will give positive voltage to a coulomb of charge, and when that charge goes through a light bulb and gives up its energy to the light energy, it'll be a negative voltage across the light bulb, loss of energy, electrical energy that is, per unit charge. And then the charges are moving around at some sort of a speed. Okay, so sometimes they're going fast, some places they're going slow. So at a specific spot in the circuit, if you put an ammeter there, it counts how many charges or how many coulombs of charges pass through that spot every second. And we can slow them down by adding resistance. Okay, by adding resistance, which is measured in ohms. So that's kind of a recap of what we were talking about for the last part of the previous video. Now I want to talk about designing a circuit. So out of all of these quantities, voltage, current, resistance, what of these can we actually control when we're building a circuit? So I'm going to bring you to the circuit construction kit here. And right now I've got a basic circuit set up, one battery, one light bulb, and I've got an ammeter installed to measure the current, how fast these coulombs are moving through, 0.9 amps. So what can I control as the designer of the circuit? Well, if I click on my battery, the simulation allows me to control the voltage for the battery. Okay, I can click these arrows and I can pump up the voltage from the battery. So that's something you can control, and that's true in real life too. Now, I mean, not really with the batteries we buy at the store, because those come with a preset amount of voltage, like a AAA battery, AA battery. All of those are 1.5 volts. I could put two of them together to make 3 volts, three of them together to make 4.5 volts. I can control it that way. However, at school, we have the variable power supplies. I showed you a picture of that in the previous lesson. It's a box that's got a dial on it, and you turn the dial, and you can actually choose how many volts you want to come out, or how many volts you want your power supply to provide. Okay, so that's one thing you have control over as the designer of the circuit. Another thing I can control is, if I click on this light bulb here, I can choose what light bulb to plug into my circuit. Okay, that's something I can control. I can research all the different kinds of light bulbs and find the one that I want. And different light bulbs come at certain resistances. And this simulation allows you to adjust the resistance too. So right now this light bulb is a 10 ohm light bulb. I could buy a 10 ohm light bulb at the electronics store, or maybe I want a 20 ohm light bulb instead. I would buy one of those instead. So as the designer of the circuit, I can choose how many ohms I'm plugging in to my circuit. So I can choose that. I'll just pump this up to, I'll just make it 20 ohms. All right, so I can choose the ohms of that as well. I can choose the resistance of a wire too, actually. So there's wire resistivity here, and right now it's tiny. It's set to tiny, which is what we're going to keep it at in grade 11. So technically, in real life, different wires offer different amounts of resistance, but hopefully the wires we choose are good enough so that it's hardly any resistance. We don't want our charges to slow down because of the wires. We want all our energy to be used up in the light bulb. Okay? All right, so we'll just ignore wire resistivity in grade 11. All right, what else can I click on? I can click on, what if I click on the ammeter? Right now it's reading 1 amp. Can I change the ammeter or change something that will allow me to select my current? When I click on the ammeter, I don't have any options. The only option is a garbage can. I can get rid of it for my simulation if I want to. But there's no slider, there's no option to change this to 2 amps. Okay, so that's something you cannot control directly. You'd have to control that by controlling the other things. Okay, so as a recap, I can control the voltage from my power source. Yeah, I can control the voltage from my power source. I can control the resistance of my loads. Control the resistance of my loads, but I cannot just tell my circuit what current to have. I cannot just choose my current for the simulation. I have to design it properly. So when I had this at 20 volts and this at 20 ohms, you may have noticed the current was perfectly 1 amp. And that's because of this formula here. Okay, current equals voltage divided by resistance. Current equals voltage divided by resistance. So when I have 20 divided by 20, I get an answer of 1. And I can set my resistance to 30 ohms. Okay, so now my resistance is 30 ohms. So if I take 20 volts divided by 30 ohms, 20 divided by 30 is 0.6 repeated, or 0.67 when you round it. I'll go back to my voltage. What if I want my current to be 2 amps? Okay, what if I want to make it 2 amps? Well, then I have to adjust my resistance and voltage so that the math works out to be 2. So if my resistance is at 30, what does my voltage have to be at to make that equal to make the current equal to 2? I'd have to make this 60 volts. There you go. 60 volts divided by 30 ohms. 60 divided by 30 gives me 2 amps. So that's kind of the only way I can control the current in a circuit or in a part of a circuit, is if I choose my voltage values and resistance values carefully. Okay, so that's what you can and cannot control in a circuit. Oh, one other thing I can control in a circuit is how I hook things up. I can either hook things up in series or parallel, or if I have a lot of things, a combination of series and parallel, and whatever I choose to do is going to make a difference in terms of currents and voltages and all of that. But that's for the next lesson, and the lesson after that as well. All right, so this is the last slide here. That formula I was talking about, you can only decide your current by deciding the voltage and resistance. Okay, so the voltage is decided by the power source. You choose the power source to decide your voltage. Your resistance is decided by the components you plug in. Okay, a 10 ohm light bulb versus a 20 ohm light bulb. So you can choose these two. Okay, you can choose these two to put into your circuit. And then when you divide the voltage by the resistance, whatever that equals is going to be your current. And that's how these three electrical quantities are related to each other. And this relationship was discovered by a scientist named Georg Ohm. So that's why it's called Ohm's law. And the units for resistance are named after him. So this lesson was really long. It had 2 videos. And they contain lots of quantities, lots of units, lots of formulas, and it's going to take a while to get used to all of them. So I'll have a Google form to get you started, but it'll probably take a few more lessons before you get used to all of these terms.